Hi guys, welcome back to my channel, and this video is about the solving reconciliation using recursive tree method. So in the previous videos we have understood what is the reconciliation and what are the methods to solve the reconciliation, like the substitution method, the recursive tree method, and the master's theorem. So in this video we'll be talking about the solving reconciliation using the recursive tree method. So what is a reconciliation? A reconciliation is a relation where we write a function in terms of its smaller input. Like if I have t of n is equals to t of, no, let's take me the example of Fibonacci series in which I have t of n is equals to t of n minus 1 plus t of n minus 2. So here we are writing this function in terms of its smaller inputs. So this is called recurrence relation. And for each and every, like for every recursive program, you can write its recurrence relation. So as we have discussed in the previous video, like when we should go for the substitution method and when we should go for the recursive tree method. So when we should go for the substitution method is like when we have only one recursive term in our recurrence relation. Here you can see we have only one recursive term in our whole recurrence relation. So in this case, we will be solving this reconciliation using, using the substitution method. But in case of the Fibonacci series, you have seen n minus 1 plus t of n minus 2. In this case, you can see we have two recursive terms. In this case, we should go for the recursive tree method. So this is the basic intuition, like when you should go for recursive tree and when you should go for the substitution method. So let's see what is recursive tree method. I will go with example 1. So we are solving the recurrence relation with recursive tree method to get the time complexity. The main objective of this is to get the time complexity. So I have example 1. T of n is equals to t of n by 3 plus t of 2n by 3 plus n. This is the question. I have to solve this. So you can see I have two recursive terms, t of n by 3, t of 2n by 3. So we have got two recursive terms, t of n by 3, t of 2n by 3, and this is another term n. So what is this? This is the cost of dividing n into n by 3 and 2n by 3. This is the cost, like this n is the cost of dividing this n into n by 3 and 2n by 3. So here we have n, we have divided into 2n by 3, so n by 3 and 2n by 3, and the cost which will be incurred for dividing n into this and this is n. You can see here. Now I have to do this, like now consider this as n, this whole as n. Now this will be divided into two parts, which will be n by 3. You can take it like as this, if this is x and this is y, you can is equals to, so this will be x by 3 divided into x by 3 and 2x by 3. This will be x by 3 and this will be 2x by 3. I am taking this whole as x and I am putting this the same which I did with n while dividing n into this. I will again divide the same thing as we did above. So if you take x, it will be better for you to understand. So what is 2x? This is x by 3 and this 2x by 3. So what is x? N by 3. So it will be n by 3 square. And what will be this? This will be 2x by 3, which is 2 into 2 by 3 into n by 3, which is 2n by 3 square. So we have got n by 3 square and 2n by 3 square. Same thing we will do like this. This will be y by 3 and this will be 2y by 3. So if we do the same thing, but we will get 2n by 3 square and 2 square n by 3 square. And what will be the cost of dividing this? Cost of dividing n by 3 into n by 3 square and to n by 3 square, it will be n by 3. And what will be the cost of dividing this into? What will be the cost of dividing this into these two? It will be 2n by 3. So what is the total? Like I have got this and this. So the total cost at this level is n by 3 plus 2n by 3, which is n. Now I will go further and I will divide this also. Sorry, I will divide this also, this also, this also, and this also. So what will be the cost of dividing this? It will be n by 3 square. What will be the cost of dividing this? It will be 2n by 3 square. What will be the cost of this? It will be 2n by 3 square. And what will be the cost of this? 2 square n by 3 square. So the total cost at this level will be sum of to this, and this. So what will we get? N by 3 square plus 2n by 3 square plus 2n by 3 square plus 2n 2 square n by 3 square, which comes as n. So now the main question is how you can find this cost. I am writing this cost here, but this can be confusing because this might be confusing because you don't know how to find this cost. So I will now discuss how to find this cost. So if I take the same example as above, this one to show you how like this cost is coming. So I'm taking the same example. So now according to the first relation given, if I divide n into these two parts, the cost will be n. So let's find the cost to just divide this into n by 3 square. I guess it was n by 3 square and 2n by 3 square. So I have the equation t of n is equals to t of n by 3 plus t of 2n by 3. So I need to find t of n by 3. I will use the substitution method. So I will find this term. What is equal? I will find the value of this term and substitute here. Then I will find the value of this term. So if I do t of n by 3, what I will get? So let's say this is n by 3. I will take it whole as x. So t of x by 3, because n by 3. So I have taken this as x. Let me take x. So x is equals to n by 3. So x by 3 plus t of 2x by 3. So x by 3, x is like to n by 3. So I will write n by 3 is equals to t of, and I have one term like n, which was like the cost of dividing. So here it will come n. Yeah, no, it will come here x. Okay, so t of x, what is the value of x? N by 3. So n by 3 into 1 by 3 plus t of 2 by 3 into n by 3 plus n by 3. T of n by 3 is equals to t of n by 3 square plus t of 2n by 3 square plus n by 3. This is the cost. So what I have seen is n by 3. I have taken n by 3. I have divided it into two parts: n by 3 square, n by 3 square, 2n by 3 square, 2n by 3 square. And what is the cost? N by 3. This is n by 3, which I was talking about before. This is how it comes. So the cost for just this will be n by 3. Now let's find 2n by 3. So this was for n by 3. Now let's find t of 2n by 3. For this, let's find out, like for this one. So let's take x is equals to 2n by 3. So what we will do, we will take x as n by 2n by 3. So now t of x is equals to t of x by 3 plus t of 2x by 3 plus, I had the constant term n, here it will be x. So what I just did, I have written this thing n in terms of x. So because I need to find t of 2n by 3. So x is equals to 2n by 3. So here we'll write 2n by 3 is equals to t of x is what? 2n by 3 into 1 by 3 plus t of just a minute, t of 2 by 3 into 2n by 3 plus x is what? 2n by 3. So what did I get? Like t of 2n by 3 square plus t of 2 square n by 3 plus 2n by 3. Here what we just see, like if I have divided t of 2n by 3 into t of 2n by 3 square and 2 square n by 3. So if you can see here, if I have divided before, 2n by 3 square, 2 square n by 3, 2n by 3 square, 2 square n by 3. So you have seen, I have got this 2n by 3 square, 2n by 3 square, 2 square n by 3, 2 square n by 3. And what is this? What is this, like this term? This is the cost of dividing 2n by 3 into this and this. So this is the cost for only this one. So what is the cost? 2n by 3. So this is the cost for this one. This is the cost for this one. I have also shown you how did I find the cost. So in this whole level, what is the cost? I have to add this one and this one. So if I add these two, I will get n by 3 plus 2n by 3, which is equals to 1. It's the same thing which I did here. So this is the way you can find the cost. So I did find it difficult to understand, so I just told you how it comes. So now let's say let's go to our like reconciliation solving. So what did we get? Like we got this one, right? I will draw another like the same tree here also. We got this. So this was n. Sorry, this was n. This was n by 3. This is 2n by 3. This I got what? N by 3 square. N by 3 square. And this is 2n by 3 square. 2n by 3 square. Here what I have got? 2n by 3 square. 2n by 3 square. And this is 2 square n by 3. Yeah. So this is the cost was n. Here also the cost is n. And here also the cost is n. So how many times I will do it? Like I will do it k times. right? You see, I will go on doing this k times. Here also I will do one and keep it going till k times. This will also be n because this is n, this is n. So yeah, so I will go on doing this k times. So if I go on doing this k times, it will be n by 3 to the power k. And what this will be? This will be 2 to the power k by 3 to the power k n into n. So we can see if we do this k times on the left hand side and k times on the right hand side, like this side and this side, we are getting this. Like if we do, see, if I do this k 0 times, k 1 time, k 2 times, same thing like k times if I do, here k is equals to 2, here k is equals to 1, here k, so n by 3 to the power k. So when I will stop when n 3 to the power k becomes 1. Okay, so what did I get? If I do n 3 to the power k is equals to 1, so I will get k is equals to log base 3 n. This is what I got from the left hand side. I mean the left side, not left hand side, left side. And if I solve this, we can write this as n by 3 by 2 to the power k is equals to 1. I will stop here. So I will get what? n is equals to 3 by 2 to the power k. I will get k is equals to log base 3 by 2 n. This is what I got from this side. So we can see we are dividing this side with 1 by 3 and this side with 3 by 2. So which side is bigger? Like this side will be bigger. Like this side will be bigger because 1 by 3 versus if I do 3 by 2, which is bigger? This will be 0 point something and this will be 1.5. So this will be bigger. So our tree will come like this. This will keep going on and this will stop. So the total cost. Now to find the time complexity, we will add this the cost only. Here you can see this at this level the cost is this, at this level the cost is this, at this level the cost is this, and at this level the cost is this. But kth level the cost is this. If I do this, like if I add this, what will get? K times n. Why? Because this is 1, this is 2, 3, and this is k. So k times n. So T of n will be k into n. This is what we have got. K times n. So k, you have seen I have got two k's. K is log base 3n and k is log base 3 by 2. K is log base 3 by 2 n. So if I put the value of k in this equation, what we will get? We will get, like, if I put this k, we will get T of n is equals to log 3 n into n. And if I put this k, log of base 3 by 2 n into n. So this will be the worst time complexity. This will be the big O of n. This T of n you can write as big O of n into log 3 by 2 n. Because 3 by 2, I have told you this is larger. Yeah, what did I write it? If we compare 1 by 3 and 3 by 2, this is larger. This is 1.5 something and this is 0.00. So this will be the big O. And what will be the theta? Like the best, the best case will be omega of n into log base 3. So this will be the worst case. This will be the best case. So this is the substitution method for finding the time complexity of a recurrence relation using recursive tree method. So thank you for watching this. So thank you for watching this video. Bye.